Alright, Chapter 6, Problem 109. This is a nifty little problem. You got a ramp, and given the angle of 37 degrees, you got a block on the ramp, and you're pushing the block with a horizontal force. And that's 50 newtons. We know that the coefficient of kinetic friction, mu k, equals 0.3. Alright, free body diagram. So we got gravity going down. We got a horizontal push force. We've got friction going down the ramp. And we've got a normal force perpendicular to the ramp. And that's the free body diagram. This is correct. Take it no further. But in the interest of saving time, I'm not going to draw another diagram. I'm going to draw my components on the free body diagram. Call this Fx, Fy, we'll call this Fgy, Fgx. Alright, now back to blue. First thing we need to find is the acceleration. What are the magnitude and direction of the acceleration? Well, let's call up the ramp positive, down the ramp negative. So after we set up the free body diagram, next comes the net force equations. So let's do, and we only have one object, so let's just break it up into x and y. Whoops. In the x direction, well, we've got F net equals Fx going up in the positive direction. Since we're doing two dimensions, why don't I just define the direction this way too, just for the heck of it. There we go. Alright, so Fx positive, Ff is negative, and Fgx is also negative in the x direction. In the y direction, we got F net equals, in the positive direction, we got Fn. In the negative direction, we have Fy. Excusez-moi. And in the negative direction, we have Fgy. And that's it, right? One, two. Yep. So there's acceleration in the x direction. We don't know what that is yet, so we'll call this ma net equals. Now we know f of x. If the ramp does this, right? So this line is horizontal, this line is 37 up, this line is horizontal, and this force is parallel to the ramp. That means by default this has to be our angle. Hopefully you can see that. And so Fx is adjacent to the angle, so this is going to be F cosine 37 minus mu Fn minus the weight is is, what's the mass of this puppy? 5 kilogram block. It's 5 times 9.8 times, yep, sine of 37. And we can fill in a little more here. 5a equals 50 cosine 37 minus 0.3, and we'll get the normal force in a sec. Actually, let's do that now. So we know it's not accelerating in the in the y direction. It's just staying on the ramp. So F net is 0. That's nice. Equals all this. So that means F normal equals Fy plus Fgy, which equals Fy is the opposite of this angle, so sine, and that's 50 sine 37 plus the weight is 5 times 9.8, and the y component here is cosine 37. So this is a straight up number, so let us calculate it on. Alright, so we got 50 sine, right mode, 50 sine 37 plus 5 times 9.8 times cosine 37. And so the normal force is 69.2. Did I do that all correct? 50 sine plus 5 times 9.8. Looks good so far. So 69.2. And we can take that and just put that right up here in the normal force. 69.2 minus all this. Well, this is just a big number, so let's just do that. 5a equals. Alright, so we got 50 cosine 37, 50 cosine 37 minus 0.3 times the normal force, which we already have here, so let's just do second answer. And minus 5 times 9.8 times sine of 37. Bam. Ooh, negative 10.3. So it looks like we're going down the ramp, or the acceleration is down the ramp. So negative 10.3. So A equals negative, divide this by 5, negative 2.06 meters per second squared. And according to the plus minus direction that we defined, that's down the ramp. So down ramp. Meaning, even though we're pushing it up the ramp, we're not pushing it hard enough to keep going, so it's going to slow down. Cool. And part C is asking, how far up does it go before it stops? Okay, I think I can fit this on here. Let me get an eraser coming up here. Eraser. Ugh, pause. Alright, erased. So, how far up the ramp is it going to go? Well, that's just kinematics. We know the acceleration. We know, what do we know here? It gives us the initial speed. So v initial is 4 meters per second. Comes to rest, 0 meters per second. Acceleration is negative 2.1 meters per second squared. What's d? So we can use this equation, v final squared equals v initial squared plus 2a delta x. This is 0 equals 4 squared minus 2 times 2.1 delta x. Let's solve that. So we get negative 16, but we bring it over here and it becomes negative 16. So anyway, the negatives are going to cancel, right? So let's just do 16 squared divided by 2 divided by, let's just do a negative to get rid of the negative that's already in the answer. And that gives us a distance of, whoa, what did I do? Hold on a sec, let me pause. Oh, it should have been 4 squared. I typed the answer of 4 squared. Let's try that again. Nope, clear. Second entry. This should have been 4. Delete. There we go. And that's also not what I was looking for. Hold on a sec. I can't do answer again because it's the wrong answer. My calculator skills are better than this. Trust me. Negative. Don't even need that anymore. Whatever. 2.06. Yada yada 5. There we go. Whoa. 3.9 meters. So delta x equals 3.9 meters. So it's going to go up that far before it stops. And part D is asking, when it reaches its highest point, does it remain at rest or slide back down the plane? Let's see if I can do this in the remaining 2.5 minutes. So, first off, it's now stopped, so static friction is present. And we've learned that static friction, F, we've learned that the mu of static is typically larger, greater than, or at least equal to mu of kinetic. So we could say that our coefficient of 0.3 is the smallest that static friction would be, and so let's just say this is the smallest force of static friction that we'll have. So if we overcome that, then we'll be good to go. So what is this? 0.3 times 69.2 is 0.3 on 0.3 times 69.2. So that's our force of friction, and we'll assume it's static for now, so that's 20.76. So force of friction equals 20.8 newtons. Now, when it's at the top, it's not accelerating because it's stopped, so F net equals 0. And that's going to equal, well, we got Fx pushing up still, and we got gravity going down still, Fgx. Now, it's stopped. Is friction going up or friction going down? Well, we have to check and see which is larger right now, Fx or Fgx, and it turns out here's Fx and here is Fgx, and if you do the math real quick, I don't have time to show you, you can do that in your calculator real quick. It turns out that Fx wins, and so friction is going to oppose that and be headed down, so we got minus F, force of friction. So since this is 0, we can say Ff equals Fx minus Fgx, and that turns out to be 10.4 newtons. And as you can see, this force of friction is less than this maximum static friction, and so we haven't put enough force in to overcome static friction. If we push hard enough so that this is larger than 20.8, then it's going to slide. Alright, time's up. Bye-bye.